meetup about aspect-oriented programming in .NET. Thank you for joining us today, and thank you, Ali, for your talk. We are glad to be back with another tech topics at VP. I'm going to give you for, information about the event and about VP Tech itself. So, during the live, I'm going to give you some tips. Please stay in the projection room during the live. It's like in the real life. If you leave a room during a presentation, you will not be able to hear the presentation anymore. So please make sure to stay in the room. Put the full screen to enjoy the talk, to make sure to watch it properly. And in case of any trouble, refresh your page or please contact vptech-communication at vp.com. At the end of the presentation, you will have an open discussion with Ali Assaf, IT architect at VP. So please keep email or them in a paper, and you will have the occasion to ask them directly to Ali and to share your mind after the talk. You will have also the occasion to visit our VP offices. And sorry for the people who is going to watch this in replay. I'm going to present you VP Tech. So as you may know or not, VP Tech is a tech community of VP. So VP is a company who has created flash shells 20 years ago. We are selling products with discounted prices from 10,000 brands to 10 European countries. We are selling our products to Sevilla, Nantes, Madrid, Lyon, Nice, Barcelone, Paris, Brussels, Amsterdam, Warsaw, and Tel Aviv. By the way, did you know that our teams are located in all of this town too? So we are a distributed team, as you saw before. We have 11 offices and we have 80 project teams, which not depend on the specific localization, which means that if 5 people in the same team are working together, they are not in the same offices. They can be in 5 different offices. It's very comfy for our recruitment because we choose the profile. We are looking for profile based on their skills, not on their geographical position. Our project teams work autonomously on their own programming language. That's why we use more than 50 technos. We can see a bunch of them just right here on the slide in our tech stack. At VP, our work condition is really flexible. We want to do our best to give to our employees the best condition as possible. We are open to discuss about the best working solution for our employees. We also propose remote days to fit their needs and desire. And we also propose dynamic and attractive processed career opportunities, such as horizontal, vertical, and geographical mobilities. Now, I'm going to present you VP Quest, the platform where we are right now. So, it's the first time that we welcome a meetup on our platform. And this platform, all this map was made thanks to our partner, Work Adventure. And all this map is based on all of our 11 offices all around Europe. So we launched this platform in May 2021. We wanted to create a common space to cross the border. And also, it's useful to take a virtual coffee with your colleague. So by creating VP Quest, we wanted to create the impression that we were all together. No matter the distance, we can join in the common spaces. You can walk and visit your colleague like in real life. We also created private conversation up to 4 people if you just want to talk to a few colleagues. We also created meeting room up to 200 people. If you want to do a meeting or something like that, it's really useful. And we also created, of course, silent zone in case if someone don't want to be disturbed. So at VP Tech, we are proud to work with a multicultural space with multicultural offices and employees. That's why we created this space to discover and visit all the environment of our colleagues worldwide and reinforce our link thanks to this platform. So thank you for your attention. And now I'm going to give the mic to Ali. And don't forget to write down your question if you have any question to ask to Ali after the talk. Thank you.
Hello, everybody. So let me share my screen. Hello, everybody. Welcome to this new session of eMeetup. It's about aspect-oriented programming. So let me introduce myself. So I'm Ali Assaf. I'm a doctor engineer in computer science. And this is a sample of my research work and article. In my personal side, I'm married with two children that occupied me a lot. And besides text, I like to read the latest update in permaculture, renewable energy, modern physics, microeconomy domain. And today I'm working at VP as an IT architect in the sales preparation domain. So today my presentation is organized as the following. I will start by giving the definition of the terms that I will use along the presentation. After that, I will give you an history about aspect-oriented programming, where the aspect-oriented programming find its grain. And after that, I will describe what is aspect-oriented programming. And after that, in dotnet, how we can do that by giving examples. At the end, we will have the conclusion of the presentation. And after, don't hesitate, we will have a question session. You will see how we will do that at the end. So the definition, what is aspect-oriented programming? In fact, it's group all the method and tools enabling the modularization of what we call cross-cutting concerns. In fact, we start from the concept that computer systems are better programmed when concerns are separately specified. So it's not because the machine itself and the computer like to see the program separated. No, it's because the developer will have more attention to what this code will do during the execution. And so cleaner and simpler code means fewer defects, so the computer system will be more reliable. So we have talked about concern. Yes, what is a concern? In fact, a concern is an area of interest. In fact, it can be functional, so related to the business logic, or non-functional, like logging and caching, for example. Also, we have talked about cross-cutting concern. We will see a lot this term in this presentation. So cross-cutting concern, in fact, are concerns that having their code scattered across all the program. And without AOP, in fact, it was difficult to program this type of concern and to modularize it. And this is in fact the contribution of aspect-oriented programming, and we will see this in the details after. So how AOP increase modularity? In fact, by providing these two important points, of fact, is allowing the encapsulation of cross-cutting concern in an entity called aspect, but also provides a mechanism that help to apply this aspect behavior across the base code. So like this, we'll no more have boilerplate code spread across the program. No, we will have each concern modularized and encapsulated in an independent module. So how AOP find the days? So in fact, it's important to see that at the beginning, aspect-oriented programming was developed as an extension of object-oriented programming. So, in fact, object-oriented programming was introduced with Smalltalk in 1970, and it becomes the industry standard since 30 years because it was incorporated in all modern language like Java, C++, C Sharp. And the idea behind object-oriented programming is to represent the real-world concept by object and classes in order to allow the developer express what he has in the mind and not having low-level code like the machine like. And the idea is to encapsulate attribute and the related behavior in the same entity called class. And after that, we will represent the real world interaction between in the real world between the entity as interaction between object. So at the beginning, object-oriented programming promise the following: the robustness of program, the adaptability, and the reusability. But how? Is by enforcing to apply the principle, what we call solid, this term we hear about every day. So solid mean S for single responsibility principle. This means that for each class should provide a single responsibility. Open closed principle, list of substitution principle, interface, and dependency inversion principle. So we know all of that. So now, in fact, for separation of concern is a key principle of software development and architecture. And OOP promised to achieve this separation of concern by the principle of single responsibility principle. So every class should encapsulate a concern. And like this, OOP promises to achieve this separation of concern. So, but let us see if in reality OOP arrived to do that, in fact. In order to answer this question, in fact, let us use the following, in fact, definition of responsibility given by Robert Martin. It's, in fact, each responsibility of a class can be seen as a reason of change. So today, for all the developer that use object-oriented programming language, ask you this class, for how many reasons lead us to modify the code of a class today? I think it's easy for not thousand, but a lot of reason lead us to change a class. So a class in reality do not have a single responsibility, and for this reason, OOP failed to provide and to achieve this. In fact, some example of cross-cutting concerns that the OOP doesn't arrive to encapsulate are, I give here some non-functional concern like persistence, validation, notification, error handling, logging, caching, and all of these concern, in fact, what we will see in our object-oriented program is that each of these concern will be scattered across our program and not well encapsulated. It's not possible with what the OOP language provide today. So, because of that, how a developer spend his time today? In fact, all the day we are striving to add or modify functionality in an existing software. We are reading the code in order to understand the business logic, but it's not easy to do that today. It's very difficult because if we look to the code, we'll have a lot of exception handling code, transaction management, logging, caching. So a new developer looking into an existing code will be lost with this tangled code across all the program, and he will not understand the business logic, and so it will be difficult for him to extend it or to fix or to change it. Also, we are copying, pasting all the day code from one place to another place because it's the same functionality. For example, for logging, we will copy and change only the message, for example. And also, we are repeating the same pattern of code. So this is a real situation in industry today. I have seen this in several places. So a lot of post-object technologies try to resolve this lack of modularization of cross-cutting concern in object-oriented language. We can cite composition filters, which is an extension of the basic object model, where we have these two concepts of concerns and filters. We have what we call the meta object protocol. In fact, it's the we can define meta object protocol is the ability of a program to reason about itself. In fact, it necessitates that the language provide to the program an access to its representation in the same language at runtime in order to modify or add or to modify the behavior or to modify the structure. We have also adaptive programming, subject-oriented programming, and at the end, aspect-oriented programming. So the goal today is not to compare and to present all of this technology, but is in fact to see how aspect-oriented programming achieves the separation of cross-cutting concerns. Aspect-oriented programming. So in fact, this term appears for the same first time in a paper called An Overview of Aspect G for Kidzales and other. In fact, in 1997. So it's Aspect G was the first aspect-oriented language. It's a general purpose aspect-oriented language, and it was developed as an extension of Java. In fact, Kidzales and the other researchers was working on meta-object protocol, and they have done a lot of work on that. But it was very complex, in fact, to ask developer and to apply this in the industry. So they have made a big effort in order to simplify this protocol and to give like a language support to explicitly modularize cross-cutting concern by implementing this language called Aspect-G. So with AOP, the cross-cutting concern as in fact represented by AM, in fact, the additional behavior that we want to add to an existing code, we call this advice, without modifying the code itself. In fact, the base code or the business logic code will stay as it, but in a separate module, we'll have the advice, and we will have what we called a point cut. In fact, the point cut will represent the pattern where the additional behavior that represents this cross-cutting concern, in fact, should be applied. And like this, we will modularize this concern is in a separated entity. So the AOP element are the advice is what is the additional behavior. The point cut is where exactly to apply this additional behavior. The aspect is, in fact, the point cut and the advice association. Also, we have an important notion is the aspect scope, in fact. So how many instances we will have per class, per object, or per assembly. So this is a simple example of an aspect written in Aspect G. It's very, very simple, in fact. We have like a class, in fact, Aspect G create an entity called aspect. So it's important to introduce and to talk about Aspect G as because it was the first aspect language. Well, the presentation today is about .NET, but we will see this after, in fact. So in an aspect, we have the point count definition, and here in an example, in fact, we are trying to match all the call to any method that starts by the word set. And this is the point count. And when we match this, and just before setting a property, we have to log it into the system. And this is what we call the advice. But technically, behind the scene, what's happening, in fact? On the left, we have a class where we call the method set side for and the object square. On the right, we have our aspect. In fact, in Aspect G, they have provide a mechanism called weaving in order to insert the advice code as we see before the call of the any method. And in reality, Aspect G will not modify the source code. What will happen, in fact, we will compile the base class called demo class in the Java compiler. we will compile the aspect with the aspect G compiler, and we will let, in fact, some meta information. And after, there is this mechanism of weaving. The mechanism of weaving will read this meta information describing the point cut and will modify the bytecode of the base classes by inserting some instantiation. For example, here I give an example. What will happen? In fact, we will compile an aspect into a normal class, but we will let the point cut in the meta information. The advice will be compiled into a normal Java method. And after that, we will insert some code in the base code to instantiate and to call the method representing the advices. So now let us to move to .NET, in fact. And in order to present that, I will proceed by example. So in my example, I'm taking a simple example of two services, cart service and article service. In fact, article service is play a role of proxy for a microservice or an API, remote API called article API. So the cart service need the article. It calls this proxy article service. So in my code on the left, it's the code of cart service. I'm calling the article service dot get article method. On the right, I have the article service that is called the HTTP API. So if I take the code, my base code of card service, and I would like to add logging before calling the method of article service. So we will see, we see in the screen the logging the logging aspect in a pink color. So, and in fact, this code is very simple, and for the moment, it doesn't take in consideration that the get article maybe can have an exception. We can have a connection or web exception. So for this reason, let us see how we can, in fact, improve our code. So on the left, we see in a gray color the code responsible for handling the exception. So when we have an exception, we will log an error, and finally we will log an error, and we will log an information because the end of the call. So after that, yeah, why calling every time this remote API? We can. It's important to have like a cache for the response. So let us add a code responsible to cache our code. So look now. In fact, the code was very simple. It was just calling get article. Now it's very complex, and when a developer try to read and to understand the method, he will be lost between all of this tangled code. What about adding a retry policy also? In fact, the API sometime can be an, or we can have a network error. So instead of returning to the final user an error, it's important maybe to have some retry policy to call the API, the article API. So let us define, in fact, using poly, which is a very known library, we can add a call that add a policy to make a retry when we have an exception when calling the API. So look to this code. It's very complex to reason about. It's very complex to extend. And all of that for some reason which is non-functional. So let us evaluate the object-oriented programming here. We have see this question. A class could be modified. In our example, this class could be modified for several reasons. If I have to change the logger, I will go to the card service and change the code. If I will have, like for example, instead of having the retry every time, I can add, for example, like a delay before calling, for example, for a few seconds before recalling the API service. I have to modify the card service. If I have to change the cache service, or to, for example, to put a timeout for the cache, I will modify my classes. So it's the SRP principle is broken here. So let us also see another point of view. So the same code of logging caching. Now we see only card service, but it's the same. It's the same problem for different classes in our program. So here also the dry principle, don't repeat yourself. It's also broken. So we see in a concrete way that OOP principle cannot be respected with cross-cutting concern. And for this reason, we can call for AOP to better and explicit separate what we have seen. So what do you think if we can just simply by putting on the top of this method, this attribute, cache, exception handling, auto retry, logging, we can have the same behavior than we have before. In fact, in this example, I'm using PostSharp, which is a industry ready framework for .NET. It was released in 2007, and it's based on a build time weaving, and it can be used in any industrial program. There is a community license, and there is a commercial license, in fact. What are the PostSharp feature? In fact, we can with PostSharp inject we can inject behavior before and after a method execution. We can handle exception. We can intercept the method call and after decide to call or not depending on the context and parameter of the method. We can also intercept property and field events, and also we can inject some attribute into existing class. In fact, some cross-cutting concern don't add behavior on existing code, but add some a structural artifact like attribute. So with this feature also, PostSharp can allow us to separate structural aspect. And in fact, the aspect that are introduced as managed resources, and we will see what is the process of build of PostSharp. So let me return to my example. In fact, it was important to present what are the features of PostSharp, but let us proceed by example. So here I have the logging aspect, the auto retry, the exception handling, simply added on the top of the method. So let me go to the code and show you how this is implemented. So here I have my card service, and here I put all of my aspect. And for the article service, in fact, I have simulated an error. In fact, I'm not doing a real HTTP call, but in fact, I'm taking a random value less than 11, and if this value is less than 6, I will throw an exception. Like this, I will have 50% of chances to have an error. And if not, if the call is successful, I will return a list of articles. So this is a proxy service called article service. So let me now describe how the logging aspect is implemented. So here I have the logging attribute. In fact, in this example, I have extend what we call on method boundary aspect. And by extending these classes, we can override the three method on entry, where here we can add the additional code to be executed before the method execution. On success is a code called after the method execution, and on exit at the end. So let me now return to my service, and I will comment the other aspect, and we'll have only my logging aspect. So here in the program, I instantiate my card service, and I call my method get article. So let us execute and see what is the output. So hello world is the main program return, and after that we have an unhandled exception error when calling API. So the logging log the entry, but after that there is an exception, and but here on exit we have exit method get article. So now let us see how we can handle the exception without having this problem. So I will return to my card service and I will activate my exception handling aspect. So let us see how this was implemented. So exception handling attribute was developed as an extension of on exception aspect. And here I have override the method on exception, and simply I will say, I will write in the console a message, and I will define the flow behavior. In fact, here I can define if the exception should be rethrow in order to be handled by another layer in my program, or there is different value of the flow behavior. I can continue, I can rethrow, throw exception, I can return, rethrow exception. All of this possibility is provided. So in my cat service, I have activated it. Here I call. So now we see that, in fact, I have hello world, which is the main program is written that. I have the logging aspect written entry method and exit method. And I have in the base code, which is the base code API has returned value. So now there is no exception thrown in my program. All the exceptions are handled. So now let me see, in fact, the auto retry. In fact, the auto retry is an aspect that extend the method interception aspect. It's very different than the what we have seen for the logging attribute on method boundary aspect, because here we can decide to not call the API if the delay is not yet passed. So let me show you the behavior now of the program. So in fact, I have, don't forget that I have in the article service a chance of 50% to have an error. So I have to repeat my program sometime in order to see, or what I will do here, I will make like a loop of my program in order to call the service several times in order to increase the probability of having an error. So here we see that for the first time we enter, we exit, so there is no problem. And after that, we have seen that I have logged method failed with exception and sleeping for 2 seconds and then retrying. So automatically, the auto retry aspect, what is he doing in fact? The auto retry, he will catch any exception defined here. So here we have defined in the constructor of this aspect the handled exception. So when we have a web exception or data exception, we will not throw it. We will catch it and we will recall the same method. For this reason, it's important to have the method interception aspect in order to have all the context of execution in order to be able to repeat it. So, and we have the maximum retry and the delay. In fact, the maximum retry, because I can define, this is a default value, how many times I have to retry the call to this API, and the delay it's in second, how many times I have to wait between two calls. So, in fact, if what's happening if I spend all my retry and the maximum retry value is at 10. What we'll do is we will send an exception into the, we will left the control flow by sending an exception, and this exception will be handled by the exception handling if the maximum retry wasn't sufficient to attend our API. So now let me introduce also the fourth aspect, which is the cache. So simply by adding this attribute now, okay, I will cache the result of get article method in my cart service. And I will no more call the API. So the cache time is 20 seconds here. Let us see. I will stay with in fact 10 with this loop of calling 10 times my cart service, because like this we will see that we'll have no call to the HTTP call. We will not have this message called base code API has returned value, because we will read the value directly from the cache. Let me execute now. So in fact, for the moment, the cache is not yet, for the moment at the beginning, the cache was not initialized, and it's important to call the method. And until here, until this line, here we have base code API has returned value, and the flow is returned to the base program. And from now, there is no call for the HTTP API. So there is no error. We are reading directly from the cache. We can we can increase this value by having, for example, 20 times this call, 200 times, and maybe by decreasing the cache time to 5 seconds. Like this, we will increase the probability of that the cache will be flashed and a new call to the API is launched. So here the method is logging, and no, I think I am very fast, and the cache will stay on will stay in fact not null, and the call will no go will and the response of the method will be read directly from the cache. So let me return to the presentation to present in fact an important feature here is the aspect priority. In fact, the order of aspect here, it's very important. It was explicitly written like this. In fact, for example, we cannot have an authorization aspect executed after the caching aspect. We should apply the authorization aspect and after the caching aspect. And a predictable order is important to prevent a broken code in the future. Even today, maybe the order of the aspect is not important, but it can be important if we add a new aspect in the future. So it's important to respect this. Here, in my example, in fact, I have used what we called aspect priority to have the cache on the top, the logging after, the auto retry, and the exception handling. Because if I have the aspect, if I increase the priority of exception handling, in fact, The exception of the web exception will be handled before by the exception handling, and like this we will no more call the auto retry. It's important to have the exception handling at the end. So the auto retry, when he fail and he spend all the maximum retry, in my example the value is given 2, now the auto retry will launch an exception, and this exception will be handled with the exception handling, and the log code will be added. So it's important to respect, to think about the aspect order. So let me continue. So there is another notion, which is the aspect scope. In fact, the aspect during the execution will be a normal .NET object. So it's important to, and an aspect also can have an internal state. So there is an aspect which is statically scoped, and another which is instant scoped. And there is a difference because we can share the same state between different classes, or we need, for example, a single state for each place in the code where we have applied this aspect. It's important to think about the aspect ordered and as a scope. So what we can do more than that with PostSharp is, in fact, PostSharp is helpful to implement some design pattern that normally necessitate a lot of code. In fact, the structural aspect that I have talked before about is the ability to introduce methods, interface, properties, and event allow us to respect this dry principle. Don't repeat yourself, because easily we can apply a design pattern into an existing code. An example of that is the iNotify property changed, which is a pattern in WPF. In fact, we see, yeah, WPF is very good. We have this pattern in VVM, but in order to implement that, C# or the platform WPF doesn't provide, in fact, what we need. We have to implement the interface, we have to implement the change, we have to launch the event. So this pattern will be crossed and will be repeated every time we want to develop an MVVM in WPF. With PostSharp is very easy to automatize and to apply a design pattern on an existing code without adding a code in the base in the business logic. Also, it's very useful to have a good domain-driven design. In fact, the goal of domain-driven design is to have a pure representation of the business logic. And it's not easy to achieve that with AOPs, with object-oriented programming. So AOP can help us to achieve a pure DDD and to concentrate our object in the business logic, and all the additional concerns maybe related to infrastructure can be added as an aspect to preserve as much as possible our classes represent the business domain and independent from any other concerns. So it's important also to understand how PostSharp work. In fact, there is two concepts: the MS build integration and the MSEL rewriting. In fact, the difference between aspect G, in fact, in aspect G, we have extend the compiler of Java in order to support this language, the additional artifact like aspect, point cat, and advice. Here, PostSharp, no, the approach is different, but it benefits from the openness of the MS build process by injecting, in fact, this library called PostSharp target and adding an additional step on the build step of .NET. So this is the MS build integration through this library. And after, the second important point is the MSIL rewriting, where it's easy to instrument the code. In fact, the PostSharp mechanism will instrument the code according to what we have described in the attribute, and the aspect will be instantiated during the build and will be serialized, and after that push it in the output assembly as managed resources. So, other AOP framework in C Sharp, we have seen PostSharp. There is also Aspect Core, Unity, Spring.NET. For Java, Aspect G, Spring AOP. For Ruby, we have Aspect R, and for TypeScript, we can add a module called TOAOP. It's important also to know that aspect-oriented programming can be also applied to functional programming, not only for object programming. At the beginning, the research in object-oriented programming led us to aspect-oriented programming. But after that, there is a lot of work that arrived to integrate this concept in functional programming also. So as a conclusion, we have seen that AOP is very useful in industrial project and microservice domain-driven design. AOP it's a excellent mix. And AOP is a matter technology. We can use it without any problem. Aspect G is used in a lot of product. For example, in Eclipse itself, it was built not in Java but in Aspect G. Microsoft also use PostSharp. So Microsoft, ABM, Intel, Amazon, all of that, they use AOP. But what we can see is that it's not well democratized for medium and small company. Maybe there is some missing of competences or in order to understand all of this future OP. So it's very important to understand that and to interact and to discuss about AOP. So here I have given some reference that I have used to prepare this presentation. Thank you, and don't hesitate to discuss with me after now is this question session. So see you later.
Sorry, Lils, you are muted.
Sorry. Thank you, Ali, for your really interesting talk. So now let's meet and talk in another room. So please join the second meeting room just up this one you're right now. Thank you.